Okay, welcome AP Computer Science students. This is just to help you review for the recursion test. Test is going to be a little bit different now that we're doing the online stuff. I'm just trying some things out, figuring it out, just like you are. And for that reason, this test will be graded on accuracy, but it is going to go on the formative grade, not the summative. All right. I also think I set it up so that you have a couple different tries, 2 tries at it. They are timed, right? You can use notes and stuff, but it is a timed time test, right? So a little bit different than what we did before. At any rate, so we're going to go through a bunch of questions. The way I'd recommend doing this review, read through the question that's on the screen, give it a shot, and then unpause the video and see if you got the same answer as I did. So here you go. I obviously marker and eraser not, but just a pencil and paper and give this one a shot and then unpause whenever you think you got it. All right, so here we go. So what happens in this is our base case. And on the test, this is they actually asked you a little bit about this language. So this is the base condition, but that's about a condition because that's an if condition. And then the base case would actually be where we print out n. Okay, and the recursive case would be when we recall the method, which is the myprint down here. So again, this is the condition, and these are the cases, the base case, and then this one down here is a recursive case where it recalls. All right, anyways, getting to the question. So what happens here is we want to know what happens when my print of 7674 gets called. And so what happens is it doesn't hit the base case. So it's going to go to the else here, and it's going to do mod 10 for our input n. So that's going to get the last digit and print it out. So in this case, system out print of the 4. Okay, and then after it does that, so it's going to print the 4 first. Then it's going to recall the method where it divides by 10, and in the world of integers, that's just going to truncate and do a 67. Okay, so now we just keep going from there. My print 67, not the base case yet, so it's going to do the mod 10 deal, right? So it's going to get the 7 and print it out. So system out print 7, right? And then it's going to recall the method by truncating. So it's going to call my print, and then just chop off the 7, so it's going to be called 6, and finally that'll be our base case, and that's just going to system out print whatever is input n. So it's going to do the 6. Okay, so in this way, it's basically going to be them in reverse because the 4 goes first, so we print out the 4, then next is the 7 and the 6, so it just prints them out in reverse. Okay, here's your next one. Again, I encourage you to pause it, give it a shot, and then check your answer with what I get. All right, so hopefully I had a chance to try it. And so our condition here is when n is 0. So generally I think we're going back, like n is a number, and then we're going to go one, call it with one less here. So we're going to work backwards. The problem is if you start with a negative number, when you recall it, so this first time it runs, it won't hit the base case, and we'll have -8, and we'll call mystery print with -9, right? And it's going to keep going backwards again and again and again infinitely because it won't ever hit 0, right? We call my print 9, and that would do my print -10, right? Sorry about the poor writing there. And then it's going to call my print -11 and go backwards and backwards and backwards, right? So that's going to create like infinite recursion or a stack overflow there. All right, again, pause it, trace through this one with the inputs that they give us for 2 and 4, and then see if you get the same thing as me. Okay, hopefully you had a chance to give this a shot, right? So what's going on here is we calling it with strange calc, where the bottom is going to be 2 and top is going to be 4 originally, right? So in this case, bottom is not greater than top. They're also not equal. So now we're going to go to the case down here, the recursive case. So it's going to be return bottom, which is 2, times strange calc, and it's going to recall it where bottom is 1 more. So now it's strange calc 3 of 4. So we want to see what happens now. We know we have the 2 times. We want to see what happens with strange calc 3, 4. Bottom is still not greater than top. They're not equal. So now we're going to recall it where we do bottom, which is now 3, times strange calc, and then we increase bottom by 1, so 4, 4. Okay, and now I think we'll hit one of our base cases. There's actually two of them here. So now we're going to hit the case where bottom and top are equal. So this strange calc 4, 4 is going to return 1 by the look of it. So this is just going to be a 1, right? So now we just have our chain here of 2 times 3 times 1, and I believe that would be a 6. So this method would return a 6. All right, you will have to program a couple on the test. So here's an example of a recursive one where we want to do base of x to the power of n, right? So it's like a power computing deal. And so see if you can figure out the code. Again, think of it in two cases, the base case and then the recursive case, which would make it one step simpler. All right, so here goes. So I'm going to do some examples first to kind of just make some sense of this. So basically, if we have power and I have 2 and 5, then what that really wants us to do, right, is to do basically, we basically want to do 2 to the power of 5. And so the trick is to realize that if I want to do this, if I do it as like a bunch of 2's, it's like 2 times 2 times 2 times 2 times 2 times 2, 5 times, right? But this right here is 2 to the 4th. So to make it one step simpler, the recursive case, if I want to do power, so I'm going to abbreviate this, but power of 2, 5, that is really going to be equal to 1, 2 times the power of 2 to the 4th, right? Because that's what this part is back here. Okay, and then you could say, well, all right, so 2 to the 4th is really just a times 2, right? One more times 2, and then do pow of 2 to the 3rd. Okay, so we can sort of see that it's staying the same. The base part stay the same, and then we just lower the exponent by 1. So the generic version of this would be we're going to do 2 times pow, and then we're going to keep the base, which I guess I could call x instead of 2, but do 2 for now, and then we're going to do n minus 1 as our power. Okay, and then the base case, I think there would be sort of two base cases possible here. Sorry, I'm kind of running out of space. I'll have to erase this in a second, but if we have power base of 2 and exponent of 1, that's just 2 to the 1st. And then if you want to go back one more step, 2 to the 0 power is just 1. So we could incorporate those base cases when we do our code. Okay, so as always, when I do my code here, I actually start with the base cases. I'm going to try and type this out. Hopefully this works okay. So my base case would be if the exponent, so if n equals 0, then I want to just return 1 as shown in red down there at the bottom. All right, and then I'm going to do an else if n is equal 1. That means we're doing something to the first power. Then we just want to return whatever the base is, which in this case is x. So that's kind of the example that's shown here. And then finally, our recursive case is we're going to recall the method. So that's kind of what I did in blue there. So else, we're going to return, and we're going to do one of the base numbers, so x, one of those times recall the method where we have the same base of x, and then just do n minus 1. So the exponent essentially becomes 1 lower, right? And that should work to compute the power for the given base number. Okay, I think this is the other one you have to write on the test. It looks something like this, where you have to take the figure number and then figure out how many squares it is. So like basically this would be our input n would be these little first, second, third. So this is like n of 1, 2, 3, 4. And then the other output would be how many cubes. So like this one has 1 cube, this one has 3, this one has 5, this one has 7, etc., etc. All right, so again, see if you can make some sense of this. Write out some code, do the whole method here, the method heading and everything, and then I'll pause the video. Okay, so I guess I'm going to call this thing num squares, but I'm going to abbreviate it because I have a hard time writing on this thing. So I'm going to call it num squares, right? And so if I'm doing num squares, let's take the last figure, the fourth figure, right? This bottom one down here. So the key to this is to realize that this is really equal to the previous one. So this part right here, these 5 are actually in this other shape. I think it's flipped upside down, but they would be right there, right? So those are the 5 from the previous figure, which can be represented by num squares of figure 3. So that right there is num squares figure 3. And then I want to add to that 2 more. All right. And so, sorry, I should add num square there. Num square. Okay. And then num squares 3, right? That's going to be just be num squares of the previous figure. So maybe I'll take a different color here. So this right here is num squares of 3. Again, it's flipped upside down. Well, actually, sorry, num squares position 2. So do num squares position 3, I would call num squares position 2 plus 2 extra blocks, right? That's what the third figure is. It's the second figure plus 2 extra blocks on the outside. I'll highlight them right there. Those are your 2 extra blocks. Okay, so when you do your recursive call, whatever n is, you just do recall it with 1 less than n and add 2. Okay, so the code, I'm maybe going to put on a new page here just because I'm not sure I can fit it all here. Okay, so here's our method heading in there, and you don't have to do the stack part. If you just a public int, that'd be fine too. But oh, I forgot to talk about our base case. So our base case is just the first figure has 1 block, right? So basically, this is the figure number coming in. That's our input, and so I'm going to say something along the lines of if figure num equals 1, we're on the very first figure. Then we just want to return 1. Okay, and then the base case is going to be a little bit more complex. So I'm going to do else, but actually not too bad. I think I can still do it in 1 line. All right, so we talked about the base case is just do 2 plus recall the method with 1 less for n, right? Because again, figure 3 here is really just figure 2 plus 2 more blocks. Okay, so basically I want to return 2 plus recall the thing, num squares, and then figure num 1 less than. Right? And if you use n there, that's probably more traditional. I just try to make my variables as meaningful as possible. Okay, so that's what she looks like. I think that's it. It's pretty straightforward. Yeah. All right, again, give this one a look over and then unpause it when you're ready to try. Okay, so what we're trying to do on this one is do a sum, I think going backwards. So if I did like print sum of say 3, that wants to be like 3 plus 2 plus 1 plus maybe even a 0. Our base case goes back to 0 though, so we just sum all those ones going backwards. All right, actually, I guess going forward, I suppose the way this is looking here, but you get the idea that you're summing all the ones that are less than or equal to 3. And the idea is that you can do print sum 3, like an alternate way to do that would be to do 3 plus print sum of n minus 1. Okay, so they pretty much have it right, except here this should be an n minus 1. Otherwise, this would be infinite recursion if you have a number that doesn't hit the base case right away, because you'll keep recalling it. Print sum 6 will be 6 plus print sum of 6 again, right, the way it's written. So this needs to be 1 less, need to be 5. So I think the answer choice that they're looking for here is D. Skip that one. All right, one last one for you. This is kind of an interesting one. I used to get it wrong when I first did it, but pause, give it a shot, and then unpause. So I think the answer for this one is that it says when will it terminate without error? Okay, and I think the answer to that is never, right? Even though it does have this catch where it just prints it out if it's less than 15, this line is outside of the if and always runs, right? And so the string actually gets longer each time because it adds 1 star to the end of the string. So no matter what string you call it with, if it's less than 15, it will print it out, but then it's going to recall the method no matter what and add a star So in that sense, it'll just get longer and longer and never end.